Hey, welcome back everybody. Today I want to talk to you guys about some big block Chevy heads. Now, big block Chevys, actually, we're talking 396, 427, 454. Now, I mean, in my opinion, I've actually got a 396 build on my channel that you can go look at. And really, the 396, the 427, the 454, externally, it's a big block and they're all pretty much the same. But internally, they are not, the bore and the stroke combination. So what you've got is, first of all, you've got the 396/402. My advice is stay away from a 396 or a 402 unless you have like a 69 Chevelle that's numbers matching and it came with a 402 and you want to keep it all original. Other than that, I mean, if you want to build decent power, 396 is not really, I mean, it's an expensive engine to build and they just don't make the power of the bigger cubic inch motors. A 427 is a fantastic motor. I did a 427 a while back for myself that I'm going to put in something. I was going to do an S10, but I kind of abandoned that project because it's too much motor for the truck. Anyway, so 427, 454, or if you want to go bigger, you can get a decent stroker kit and make a 496. One of those three motors is a way to go. Now, I understand there's a lot of aftermarket heads available that are, you know, going to make really big power. But if you're on a budget, which a lot of you are, there is a set of heads. There's a couple of sets of heads out there. They're not the square port heads. They're the large oval ports from the 70s. And what you're looking for is a 781 casting or an 049 casting. Now, this is an open chamber head. It has anywhere from 116 to like 122 cc chamber. I think the 049s are a little bigger. I've cc'd them quite a bit and they vary. But they average probably about, the 781s average probably about 115, 116 cc's. So you're gonna have to have, especially with a 454 or 496, you're gonna have to have a dome piston in there because that's a big chamber. Have like a flat top or a dish piston, you're gonna have really low compression. I would recommend, if you're building the motor and you're on a budget, get a set of these heads, but definitely you're gonna have to figure out your compression ratio and you need like 120 thousandths dome on your piston to get like around 10 to 1 on a 454. All right, so anyway, here's the thing. These are the best flowing oval port head, stock production head that GM ever produced. Now, I understand there's the big square port heads, you know, there's always the LS6, 454 and all that. I understand all that. Here's the thing though, for the street and especially for a budget, number one, the square port factory heads are so outrageously priced and so rare anymore. You know, again, it's kind of a numbers matching deal. If you want to have an original LS6 SS454 Chevelle or something and you need, you know, a set of square port heads to make it numbers matching, fine, go ahead and spend the money. If you're building a street rod, and also I would say that the 781 large oval port head actually outflows the square port head in the entire RPM range or in the entire lift range of the cam up until about 600, 650 lift. And then, of course, the square ports take over and they kill the oval ports. They flow really well upstairs. But the problem with that big square port is they tend to be kind of sluggish on the low end, especially if you've got like a 427. The large port, they don't have as much throttle response and low end torque. So you really got to trick out the motor to zing it up to high RPM. So for the street, the large 781 oval port is actually a much better choice and you're going to be much happier on the street with it. So here's the thing. What I would recommend is the 781s and the 049 just come with a standard 454 intake and exhaust valve, the smaller valves. The square port head had a much larger valve in it. So what we do is we upgrade the 781s and the 049s with the bigger valves. Now, with no porting, 454 with about 11 to 1-ish compression with no porting and just the big valve upgrade. We've seen north of 550 horsepower out of a 454 with the 781 oval bore to the 049. That's pretty dang good for a set of heads that you can pick up relatively cheap. So, and again, I realize there's a lot of aluminum aftermarket stuff, but I've done the aluminum heads, the cheap aluminum big block heads, the ones that are made overseas or whatever. And I'll be honest with you, on the dyno, I don't see much improvement over the 781s or the 049s at all with those heads. I mean, they are lighter and they're aluminum, but power-wise, you know. Now, when you get into AFRs or Dart and aftermarket, good aftermarket heads, good quality heads, now they're going to kill the factory heads. You're just going to make, way more horsepower with those. But you're talking about $3,000 for a set of AFRs, where you can do a set of 781s at your local shop. By the time it's all said and done, parts and labor, you're into these things for $800 and you're making north of 500 horsepower. That is a pretty good bang for the buck if you're building a big block. So my personal 427, I have a set of 781s on that are ported. Now I did port mine and I put the big stainless valves in them like I'm going to show you today. So I've got the heads here. All right, so our first order of business here, you guys, is to put valve guides in. Now, there are some different procedures for this. I want to show you this tool here. This is what they call a knurling tool, and what it does is it just kind of, you put it into a loose guide and you run it down with the driver, and it kind of threads that guide, and it pulls metal from the guide and makes it smaller, and it kind of threads it. It's called a knurl, and it just tightens up the guide. This is not the right way to do guides, man. I'm telling you, this is just a cheap, get you by, we want the thing to run for one more year type cheapy job. If you're going to actually repair a head correctly, we have to bore the guides out. Some heads have guide inserts, and actually big blocks have guide inserts, but they're water cooled, and a lot of times if you drive the guides out of these, they leak, especially on the exhaust. So we don't really want to do that. So what we do is we take a thin wall guide. So we've got a new set of guides that we bought here, and this is actually a replacement guide that's going to go in there. And it's a press fit. So what we do is we have a drill here called a core drill, and you can see it's piloted. So it actually pilots into the existing guide down here once we get the head centered, and then we just bore that out. I'll show you how we do that so we can get this guide in. Alright, so we have actually punched a 1/2 inch diameter hole all the way through that guide. This guide here is about 502, 503, and we're going to use a driver once we clean all that out to press it in. And now at that point, we just take our guide, we want to oil this up because it is a press fit, and you want to get some oil on the inside diameter of that bore. And we have a pneumatic guide driver. And we just take our pneumatic guide driver and we take our guide, and it goes right onto the end of that. And then we're just going to use, it is a press fit, so we have to drive that guide in. We want it to be a press fit because we don't want the guide falling out when the head heats up. And we just go in until we get flush, and now we've replaced or restored our valve guide. Now I'm going to go ahead and do that to all the rest of these. I won't do it on camera to bore you, but once I get all the guides in, I'll come back and we'll talk about what we're going to do next. Alright guys, so we got the intake guides in. Now, with the big block Chevy, because the intake and exhaust valves are at a different angle, the intakes are one setup to get the guide true with the cutting head, and the exhaust is another angle. So what we do to be more efficient here is we're going to do the intakes on both heads. So now you can see that the intake guide is in, we bored it out and we press it in. It's actually sticking out over the top because it's basically just a generic bulk type replacement guide, so it's longer than it needs to be, and we got to trim that down. The other issue is we're running dual springs on this, and so the standard big block Chevy valve stem seal is going to be, this is one of the old seals, it's going to be way too big for our spring kit. So if you remember, Mrs. Vintage Iron picked up our dual spring kit. Normally a big block Chevy, just a stock spring, is just going to have a single spring like this, and it's no problem for that seal to fit under there. But see, we've got a dual spring set up here because of our big roller cam we're putting in, and there's no way that that seal is going to fit under that inner spring. So for a couple of reasons, we have to cut those guides down. Also, we're going to trim it down a little lower to give us more lift capability. This is what we call a PC, or a positive seal cutter, and this is just going to go on. And I'm going to go ahead and show you how we do this. We got to trim the guide. This is going to trim the guide and give us the right height and give us a chamfer on it. So this is a cutter that we use to get the height and the diameter of our guide correct for that inner seal. All right, so now at this point, we've got this set up so that we can cut and trim that guide down to the correct height. So that's the height that the guide was originally, right here. I'm going to go ahead and set my machine up here. I have a height gauge, and I'm going to take another 60 thousandths off of that, just to give us a little extra clearance. That's it. That's all there is to it. Now, I will go in, of course, and trim all of these off, but I wanted you to see that. The other head on here, and I'll do all the intakes, and then we'll change the setup of the machine and we'll do the exhaust guides. But the procedure is pretty much the same, you guys, for the guides. I just wanted you to see that. So I'll get all the rest of the guides in and get them trimmed, and then we'll talk about what we're going to do next. But one thing I want you to make a note of here is that now we've got the diameter of the guide down to the point where our seal, we bought a special seal that's designed to go with this inner spring, and now that seal, once this spring is on, is going to have no problem clearing the inside of our inner spring. So that's, when you upgrade to dual springs, that's something you got to consider. You're going to have a machine shop machine these guides for you. Even if you don't put guides in, you're still going to have to trim these down so that that inner spring and seal can fit on there. So hopefully that makes sense to you. All right, so I'll get the rest of these done and then we'll come back. All right, so you can see we've got the head set up, and they do have a canted valve, so we got to do some funky angles here to get the machine to cut the seats true. So what we're going to do is we're going to take that dinky valve that's in there. So these are the factory valves, just the old wore out valves that came out of these heads. This is, I don't have all the valves here. Mrs. Vintage Iron went to pick up the valves. I have a couple laying around, but this is the replacement valve. So this is our replacement exhaust valve. Now this exhaust valve that we're putting in is 1 inch 880 thousandths. You can see that it is quite a bit bigger than the stock valve. If we measure our stock valve here, it measures about 1 inch 740 to 750, somewhere in there. So 1 inch 750, we'll say. And then, of course, that's the size. We got to open this way up out here, and we got 1 inch 880. So we're adding a pretty good amount of valve area to that seat by the time we're done. Of course, we're going to have to machine them for that. And we also have to unshroud the chamber a little bit. But yeah, so these small valves are going away. Now your intake valve, your stock plain Jane type 454 intake valve, is about 2 inches and 90 thousandths. If we take a look at the replacement valve that's going in, you can see there's a significant difference. And if we take and we look at that, we got to open this thing way up again to get on this valve, and we're at 2 inch 110 thousandths, 2.110, which is over 100 thousandths bigger. So we're taking the valve area, and on these heads have phenomenally good flowing ports. The valves that are in there, the stock valves, are a little restrictive, to be honest with you. So we're going to take and we're going to open those up, and these are actually the valves, the sizes that come in the factory square port heads, so like the LS6 head. So we're upgrading to the bigger valves, and we're going to cut the throats and so forth. And like I said, this upgrade, you can have this done by a local machine shop. You need to find one that's worth their salt, but you'll see well north of 500 horsepower if you get the right piston and so forth, and the right cam combination, intake and exhaust in this thing. These heads will support that kind of power. So now that we've got it on the machine, I guess I'll just demo this. I'll show you a little bit of machine work. I've done some videos where I did this before, but I didn't really explain it very good. So we've got this set up for the intake, to cut the intake. And there's several ways to do this, but we're just going to go ahead and use a multiple angle cutter that we have. We're going to set it with our fixture based on our valve size, and we're just going to go ahead and cut the seat. So I'll get that set up, and you can take a look at how that works. Okay, so you can see, if you compare this port here, we've significantly cut that throat out, or opened that throat up, and that's going to give us a good area under our bigger valve. So we put our valve in there. You can see we're pretty close now. We've got a good area under the valve, and now we're going to go ahead and we're going to set our valve up on a fixture, and we're going to put our multiple angle cutter in there, and then we're going to cut that. Alright, so here's what we did, guys. We took our valve, put it on our fixture, and we located our pointer on our fixture right at our 45. And then we went ahead and put our tool in there, and we adjusted our tool so that the 45 angle, this has multiple angles on it, the 45-degree angle on our tool matches our valve. And then we just go ahead and we slowly machine that, and you can just see, you can kind of watch those angles appear. And once all three of the angles appear, then we're done. We're cutting for our seat. So we'll get in on that so you can kind of see what's happening here. So you'll see as we go down, it's going to start to cut those angles in that seat. See the angle starting to appear there. And there we go, we've got all three of them. So we'll take our pilot out. We want to get the chips out of there. All right, now you can see that we're really close to where we need to be. Now we're gonna fine tune that, probably lap that in and maybe touch it with a stone if we need to, but that's really where the valve is gonna sit. If you look over here on the one that next to it that hasn't been cut, you can see how much higher that valve sits because our seat's not located where it needs to be. But now that we've got them cut, we've got our throat cut down here, opened up for better flow to match our valve, and we got our seat angles on there. And your valve seats in just like that. Now we're going to do the same thing to the rest of them and also to the exhaust. One thing I would say is that the exhaust seats on these heads, the nice thing about the 781s is they have a flame or induction hardened exhaust seat. So you don't have to put seat inserts in here. You can just go ahead and cut it because they're already hardened and ready for unleaded fuel. So that's one nice thing about these heads. All right, so I'm going to get the rest of these cut and then we'll come back and hopefully the little lady will be here with the parts. So it looks like you picked up some parts, huh, Mrs. Vintage Iron?
Yes.
What do you got? You want to walk us through this?
Well, since you're doing the 781 big block head, we decided to upgrade to big stainless valve. We have a 1-inch 880 exhaust valve and a 2.190 intake valve. These are significantly larger than the stock valves. And the reason we're doing this is because it's going to give us a lot more performance out of our 781 heads.
You're a big block gal, aren't you, Mrs. Vintage Iron?
Yes, I am.
So, what do you think about V6 powered convertible Camaros?
Those are for high school girls. Real women drive big block powered cars.
Oh, I love it. That's great. Okay. So what else do we got here? You got another box there. Mm-hmm. That's our springs, I take it.
Yes, these are our comp cam dual springs. This is going to match the cam we're putting in.
So are the valve springs important?
The valve springs are very important because you have to have the correct opening and closing pressures, especially when we're going with a radical cam like we're doing on this build.
All right, folks, so I got the intake and the exhaust cut. Now, one thing I wanted to point out here, I mentioned earlier that the 781 has a hardened exhaust seat. What they do is they induction harden or flame harden this area. They don't actually have a hardened insert in here. But one thing that I want you to look at here is this. If you look at the throat that we cut on the intake, it's all just the same basic cast iron color. If you look right here, you'll see that this is cast iron down here, but it changes color. It gets a lot darker right here and a little bit shinier. And you know, you do enough of these, you can tell what your cutter is doing. So when you cut these exhausts, you can hear your tool is actually struggling. It has more of a high-pitched sound, and you can tell that it's working a lot harder to cut through this hardened area. So there's actually been some controversy on these heads. People say, oh no, they don't have hard seats, but I can tell you I've cut a bunch of these and they do have an induction hardened seat, and that's what that different color is there. And you can see it's on. If we back out here, you can see that that discoloration or that hardness is on every one of these exhaust seats, and the reason that they do that is they're prepping the seat, hardening it to make sure that it's going to be compatible with unleaded fuel. When we had lead in the gasoline, it created it left a coating on the valve in the seat that protected it, but when we went away from leaded gasoline in the early 70s, they had to harden all these. So that hardness is pretty thick also. I've got the throats cut way out a lot wider than they were. That's about where the throat's going to be. And now all we got to do is put our seating angles on here, and we've got our seating angle is going to be right up here in this area, and you can see how deep that hardness went. So definitely has hardened seats for unleaded fuel. Fantastic heads. All right, so I got all the guides in, I got the seats cut. I'm going to vacuum this out, and we're going to move on from there.